Guys, we are going to be solving an interesting problem. uh, yeah, it's actually an interesting problem. So it's a problem with institutions that are wanting to properly understand existing transactions, and they've not been able to classify this is a fraudulent transaction or this is not a fraudulent transaction, but they are wanting to see from this particular transaction, are there deviations from the norm? For example, a customer of a particular fintech who does about 70 something transactions per day, per day. And so we are wanting to understand this customer transaction and look for something that feels like a deviation from the norm. So and this is where anomaly detection actually comes in. So anomaly detection is used when you want to identify data points that deviate significantly from the norm. The goal is to find instances that are rare or abnormal. So we're not just going to be checking out for anomalies from this particular transaction. I'm going to show us the transaction shortly. We're also going to be segmenting transactions. When we are done with checking out anomaly, we're going to be segmenting transactions. So this is when for instance, the fintech, you as a fintech, you use anomaly detection when you've not been able to classify your transaction fully, either it's fraudulent or not fraudulent. Even if you've classified, you might want to edge on both sides. You have a model that classifies fraudulent transaction or non-fraudulent transaction, and you also have another model that does anomaly detection, and both of them are working simultaneously. If the both conditions are true, then that particular transaction should be honored. Oh good, that's how to edge your security advantage before you approve a particular transaction. Now, like I said, when we are done with the anomaly detection, we're also going to be looking at segmenting that customer's transaction. So in terms, and this is where clustering comes in. So we are also wanting to give the particular customer insights with transactions, his transactions that are similar, so similar occurring transactions. So we're going to place his transactions, group them. We're going to group them based on groups that have similar properties. So clustering is used when you want to group similar data points together based on certain features. The goal is to identify natural grouping or patterns in the data. So very quickly, let's go create a project. I'll call this personal finance insights, anomaly detection and transaction insights. Well, that name looks quite lengthy. Personal finance anomaly detection and insights, because we're going to be doing two things from this particular data set. Good. So let me quickly show you the data sets. So we can see this is a data set of a single individual. On this particular date, he transacted with his platinum card on Amazon, and he paid for a service that is worth $11.11. So there was a debit from his card. And yes, shopping category. So this song who just shopped from Amazon. And on this other day, there was another debit again from his card of this amount, and mortgage payments. It was paying the service provider who has provided it, and it's coming from the checking account. Thai restaurant, $24.22, and there was another debit, and it was a restaurant expenses. Now the institution, the company ABC, the fintech that sees all of these transactions, is firstly they want to understand, okay, what transactions from this same customer seems suspicious. And there are several things, and this is where anomaly detection comes in. What seems suspicious? So we've not been able to categorize and say this is suspicious, this is not suspicious. Okay, what seems suspicious? What seems not like a normal transaction coming from this individual? Because data has patterns, and in these data patterns, so we're going to build an AI model that understands these customer patterns, and when a new pattern is coming in, it flags and say, oh, there is a shift in this customer behavior, and so the institution can now decide how they want to treat that particular shift. So ways they can do it, one option is to they can demand an extra form of authorization to be sure that is that particular customer that owns the account. So this is where 2FA comes in, exactly. And they can have their own internal policies around such. Either they want to block that, disable that particular account, depending on how sensitive that transaction could be. Beautiful. So yes, we're going to be building first two models from this data set. Firstly, the anomaly detection, and secondly, the clustering, bringing out segments off from this data set. Now, this is not just a finance problem. It can even be a venture capitalist that is also wanting to segment various startups that has applied, based on funding, revenue, marketing spend, R&D spend. You want to segment each of these customers. Yes, so this where segmentation also comes in there. Oh, anomaly. There are multiple other. It can even be an e-commerce business or whatever other sector. You take transactions from different customers and you want to already understand which transaction seems very far off. So meaning, so you have built a model, let's say a transaction fraud detection off of Autogon AI, a classification model. And for you to build such supervised learning model, you would have provided the labels of transactions that are fraudulent and transactions that are not fraudulent. Then also you want to edge your security and also build an anomaly detection, so you can already see transaction patterns that are very unique. And it's beautiful when you understand unique transaction of a particular individual and unique transaction of all your customers. So yes, you can edge your security from multiple points. Good. So let's go ahead to further examine this data set even as we go build our first model, which is the anomaly detection. So we can see on this date, he went to a physical hardware store and he used the silver card, and yes, category home improvement, and he bought a physical hardware for his house, and there was a debit of $18.45. Good. Before we dive into building the model, I love to take advantage of data analytics to have some extra insight about my data set before I build models. It's a good practice. So I'll just click on this auto visualization and give it some little time to run. And I'm very interested in the car var plot. Good, beautiful. So I can see straight away from this car var plot, all this category to amount, and I can see that paycheck has the is the category that has the highest amount, followed by mortgage, and followed by home improvement, and followed by credit card. Great. So another thing again I want to look at is which of the accounts had the most transactions. So I can see the checking card. The checking account had the most transaction. Then the platinum card and the silver card were almost at par. I want to look at description, and I can see that Most of it went for mortgage payment, and Mike's Construction Co. So yeah, had the most transaction description. Then we look at transaction type, and yes, we can see that this transaction, there is more credit transaction related activity than a debit. Beautiful. So one more thing before we dive in building the model, I want to check out this model. We ask your data. Firstly, you have to ensure your data set is not a very large data set. Yes, so for now Autogon GPT works with not so much of a large data set. So, and I'll ask a simple question. Okay, let's start with show me some interesting insights from these data sets. Okay, we'll give this some seconds to run. Okay, so we can see total amount of money spent for each category, and yes, we've seen something like that too at the auto visualization chart. Credit payment system, this home improvement, yes, we've seen something like that. And average amount spent per transaction, so beautiful. I can see for the credit and I can see for the debits. And there's more inflow, higher amount of money coming from the credit end. Total amount spent per account name, and yes, we've already seen statistics around this, and the number of transactions per month, and we can see that 2018 December had the highest number of transactions. We can continue to add some interesting prompts and get some interesting statistics off from our data set, but let's dive right in building a model. So I'll call this, so I'll head towards project, create project, and I'll call this personal finance insights. Okay, personal finance. So if I call it finance insights, and yeah, so insight basically finance insights. Good. Okay, beautiful. Now we're going to be using Studio Wizard for this particular problem that we're going to be solving. Yes, we can also do it on Studio as well. So Studio Wizard is an auto ML tool of Autogon AI, while Studio is a tool that allows you to do all of the heavy lifting as to your own data preprocessing, building your ML models, and doing a whole lot of interesting stuff right from the ground up. Good. We're going to be using Autogon Studio Wizard for this particular problem, and we'll launch Autogon Studio Wizard. And firstly, we said we're going to build out an anomaly detection first, and then we keep the model on one side. We inference the model. Then the next thing, from this same data set, we're going to build out a clustering model that understands the clusters that exist between each of our each transaction of that particular customer. So we come straight to select data set, and we select personal finance. Okay, so beautiful. We can see the mean of this, but yes, we're not interested in any of this for now. We just click next, and we'll go straight to anomaly detection, and we'll call this model anomaly model. You can use whatever name, and then we hit on the train. I will give this some seconds to run. Beautiful. Now, from these statistics, we can already see for the anomalies that was detected from our transaction. You can see this is a 3D plot, and you can see from this region we can see our anomaly items with a strong yellow. So we have an anomaly here, 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 and we can always interact with this chart. We click on this and we can use any of these commands. Firstly, from zoom, let's look at this anomaly. Okay, so we can see the interesting mappings of these 3D charts, and so this guy 2018 0505 20 is under 2019 2018 2019. So good. We can also do some rotation if we want to see more of the 3D shape. You can come play with the chart here. We can also use the turbo rotation to play with this 3D graph. Beautiful. Now we've been able to see that the anomalies are not so much, but yes, let's go get this anomaly. And to get this anomaly is as simple as we hit on the prediction. We want to see those exact columns, those exact records that has the anomaly, and I have the data set open there. I'll just copy the data set link directly and take it to this test data set, and I'll put here and I click on predict, and beautiful, we can already see our flags on anomaly. So you take note of this anomaly column, and you can see each of these ones are not anomaly. No anomaly here, no anomaly here. This is an anomaly. So our model has predicted that, oh, this particular transaction is suspicious from the normal transactions that it sees. So let's further look for another anomaly. So not so much. This is another anomaly. So this particular transaction is suspicious. So already I've already explained what you as an organization can already do with suspicious transaction. So you can go ahead and download your YPred and and do some interesting stuff with it. Now let me show you how to. Now we have built this. We've built a model. Let me show you how to create a pipeline and carry out this transaction from the pipeline. All we need to do is we save anomaly pipeline, and we create a pipeline. Beautiful. So if we go to our home page on quick predict, so this is for customers who are going to be inferencing the model that they've built from through the API or through the quick predict region or through their backend code. Now it's as simple as the fintech needs to find time to, so you push your data sets to Autogon AI and you build a model on the fly for that particular customer or for your entire customer, an anomaly detection model. And after you've done this, you can then begin to pass an instance of a transaction to determine if it has an anomaly or not. Good. So all we need to do from here is we can even impute the direct dataset link here. We can impute the direct dataset link here, and we select the pipeline that we have created, and we inference. And you can always download this, but we're going to predict an instance record here. We predict for this particular guy. We take this right here and we'll create a data set, select one dimension, and we copy this, come to input link, replace it here, run, select the pipeline, and we inference, and it tells us, oh, this transaction is free, it has no anomaly. And yes, we could always take this to our postman, and yeah, I already have a postman collection open here. Replace the data set. To copy the pipeline that we've built, click on your project, click on the finance insight, and copy the pipeline. As beautiful as that. Come here and update the pipeline ID, and when you hit inference, we'll get a prediction. You hit on the prediction and you open, and it tells you this transaction is free. So this is how a fintech can send a new instance of a transaction to determine if this transaction has an anomaly or not. An anomaly means something is odd about this transaction. Beautiful. So now I've showed us how to build an anomaly model off from our data sets. So the next thing we're going to do is, from this same data set, we're going to cluster each of the user's transaction. So we want to see what transaction patterns seem similar. We want to put it in form of a group, and this is where clustering comes in. Yes, so we want to group categories of transaction together. So clustering is used when you want to group similar data points together based on certain features. The goal is to identify a natural grouping or patterns in a data. So we can see there's Amazon, we can see the amount, we can see the dates. So the goal is a natural intelligent grouping, not necessarily putting all dates of the same day together or putting all transaction description of Amazon. We're wanting to put similar behavioral pattern, similar groups together, exactly, and we can then show this insight to our end users, or make decision from our end users as to how they use our platform. Good. So we'll go back to our project and we'll click on the finance insight. We'll click on Studio Wizard. We select same data set, personal finance data set. Beautiful. And the next thing we're going to do from here is we'll come to training type, and this time around we select clustering. You guessed right. Good. So I will enter a model name and we'll call it clustering underscore model, and we'll click on train. We give this some seconds to load up. And beautiful. So we can see already that our model has actually clustered, categorized this user transaction into 4 categories, and you can see cluster 0, cluster 1, cluster 2, and cluster 3. And you can always interact with each of these charts. Zoom in, zoom out, turn it. Yeah, good. So we can see cluster 0 is of this color. You can see cluster 1, and we see 2 patterns around this cluster 1. Cluster 2, we can see how distant these cluster 2s are, and cluster 3, we can see cluster 3 not so far from cluster 0. Good. So the next thing is We can then build a beautiful insight from this, or we can inference our entire data set. So meaning we take this entire data set and we click on predict, enter the data set here, and we predict because we want to see all the clusters for each transaction. And yes, here we have it. So you can see this transaction is on cluster 0. Now from the top of my head, what I'm seeing already about cluster 0, I can see cluster 0s have a low amount, 24.2, 24.2. Yes, and it's a debit, 24.2. Another cluster 0, 11.76, 25, 18, 45. Yeah, so we can see there's a pattern that cluster 0 have. So let's just take note of this cluster 3 even as we enter the next page. So we can see for that cluster 0 has a low amount, lower than 100. Good. So we can see cluster 1, 2000. Another cluster 3 here, 554. Don't forget on page 1 we saw a cluster 3 here of 1, 2, 4. So okay, it's different. So the model just learns of the patterns. 554, and this is a credit, this is a cluster 3, this is a debit. So the model learns of the patterns and classifies similar transactions based on the user's behavior, and again it's also considering the dates. So I am not an algorithm. So all of these behind the scene of some very interesting statistical algorithms put together to study patterns across your data and come up with a very great accuracy. Good. So now that we've clustered these users item, we can create a cluster pipeline. And there's several things we can do from this as a business. Good. So now it's either we inference all the data set and see, which we've done already. We inferenced all the data set and we can see it already, and we can return these interesting categories and do some extra statistics across categories of each of the clusters and send it to the user's mobile app. Or we then look at each cluster and then try to understand the behavior of each of those clusters, and the next thing we can do is to now tailor some interesting advertisements for the user, or we can bring in some further recommendation to aid buying behavior. So if we see that a particular cluster favors our business more, the user is having to do something that gives the business more profit, we can try to see how we can move the user to do less cluster 1 activity and move him to a cluster 2 activity or a cluster 3 activity. So yes, so as a business, it's very important you are making interesting data-driven decisions from your customer data, understanding the patterns, because data has a soul that needs to be learned. Data has likes, has dislikes, has your customer behavior, how they utilize your platform, has if they are going to churn or not, as if they are enjoying their experience from the time they spend. So the more data you put together and study these patterns, the more you make much more important decisions based off from your customer data. Interesting. So we've created a pipeline. Or have we created a pipeline? Yes, we've created a pipeline. We can always inference this same data set from the pipeline or a sub data set from the pipeline. So I can take this particular observation and I go straight to the pipeline. I select finance and I can say clustering underscore model. I can create a data set off from this, select one dimension, and I copy it I input the link here, run model, select pipeline, and select the cluster. And we're wanting to see, oh, for this new transaction the user is sending, or we can see this new transaction is actually a cluster 0 transaction. Beautiful. And the same way we were able to predict anomaly via Postman, that's via the API, we can also predict if what cluster this category of new transaction this customer is sending falls under, and the business are taking the appropriate action towards that particular transaction. Thank you very much.